Hi guys, in this video we're going to have a look at interpreting histograms. So if you haven't seen the video on how to draw them, definitely watch that one first because that will help you with this. Okay, so in the drawing histograms video, I've left you with this, where the bar area, the area of each bar, represents the frequency or how many people are or what the speed is in miles per hour in this particular case. Okay, so the area represents the frequency. So if you have a histogram and the question is work out or fill in the table where you have to work out the frequencies, just work out the area. So if we have a look at the class width, 20 and 20 here, so the class width is 20. And the height of this bar, I know it's frequency density, but the height of it is 4. 20 times 4 is 80. So the frequency for this particular grouping is 80. This one here, the class width is 30. Times that by the height, which is 6. 30 times 6, 180. Next one, the class width is 10. Times that by the height, which is 7. So we have 70. Next one here, class width is 20. Times that by the height, which is 2. So the frequency there is 40. And the last one, the class width there is 30. Times that by the height, which is 1, which gives you 30. Okay, so to work out the frequencies, all you do is just work out the area of each bar. As a little bit of an extension to that, they could ask you to estimate the number of people whose average speed was between 10 and 40 miles per hour. So to do that, go up from 10 and from 40. And then you just work out the area of this bit here and the area of this bit here. So let's do the first bit there. So the area would be 10, class width is 10, times by the height, which is 4. So I have 40. So that bit there is 40. And this one here, so part number 2. The class width is 20 times by 6, which gives me 120. And to answer the question, you just add it together. So the 40 plus 120 is 160, which would be your estimate for the people between 10 and 40. So similarly with this one here, estimate the number of people whose average speed was 40. So 40 is that line there again. And 70. So I'm just going to draw the 70 line on. And I want 1, 2, 3. So 1, 2, 3. Those sections there. Okay, so everything in between 40 and 70. So number 1. The class width for this is 10 times by 6, which is the height, which gives me 60. Number 2, class width is 10 times by the height, which is 7, so 70. And number 3, class width there is 10 times 2 is 20. And add it all together, 60 plus 70 plus 20 is 150 would be your estimate. Okay, so the key thing here is the area is the frequency. Right, let's have a look at another type of question that you may have. So in this one, I have my histogram here. I don't have any values for my frequency density. And I have one value for my frequency, and I need to complete the table. Okay, so let's work with what we've got. I've got my frequency here to be 40, so this is why it's crucial to I've watched my drawing a histogram, because we're now going to work out the frequency density, which is the frequency divided by the class width. In this case, the class width is 5. Which is 8. So the frequency density for this particular one here is 8. So between 45 and 50, which is this column here, I can now go across and say that is 8. Okay. Once you have a value on your y-axis, you can then fill in the rest of it. So obviously halfway would be 4, and in between 0 and 4 would be 2, and in between 4 and 8 would be 6. So we're going up in 2, so 10, 12, 14 and 16. So we could fill in our frequency density for the first one. It's 12. Then the next one would be 4. This one would be 16. And this one here would be 6. Okay. So once you have that, going back to what we said in the first example, work out the area of each bar to get the frequency. So the class width here is 10 times by the height, which is 12, which gives me 120 for my frequency. And you can check it as well, just by going the frequency, which we think is 120, divided by the class width, which is 10, you get 12. So it all fits in together, so you can check as you go. This one here, the class width is 20. Oh no, sorry, it's 25, isn't it? Yeah, be careful there. Is 25. Times that by the height, which is 4, so it's 100. Next one, the class width is 10. Times by the height, which is 16, which is 160. Again, we had this one here, so we've got the 5 times 8, which is 40. Yep, that's fine. And then this one here, the class width is 30 times by the height, which is 6, which is 180. Okay, so just from that one bit of information, I could then get my y-axis complete, and then by that I could then work out the rest of the frequencies. Sometimes I'll just give you one value and you have to complete the histogram, so there might just be 1 or 2 bars in here, but either way, whatever you've been given, work out the scale, and then you're in business. Okay, that's a very common type of question. And I've just got one more for you, which is this one here. Now, I've deliberately picked this one because a similar question came up 2 years ago in the actual exam, where they gave you a histogram, they asked you to complete in the table, but the only information they gave you was that the histogram, well, in this particular example, they tell you the total. So the histogram shows information about a total of 250 cars. So the way you can tackle this, there's a few ways, but I think this is the best way, is we know that the area of each bar is the frequency. So if I work out the area of every single bar here, it should equal 250. Now you might notice I've deliberately used graph paper on this to make it a little bit easier, and this is probably what you'll have it on in the exam. So what I'm going to do is I'm going to count how many squares I've got in each bar to represent the area. So that's quite easy along there because I just look at the class width, which is 15. So I've got 15 squares along there, and 10, 20, 30, 40 squares going up there. So I just work out the area. 40 times 15, 600 squares. There's 600 little mini squares in that bar there. Same thing here. I have 10 going there, and I have 10, 11, 12, 13 going up, which will give me a total of 130 squares when I times them together to get the area. Next one, 20 along the bottom here, and I've got 10, 20, 25, 26 going up there. So again, 26 times 20 gives me 520 squares. Now if I add up all these squares, I have 1,250 squares, which is the total. And I know the total amount of cars is 250 cars. Okay, so I know that 250 cars equals 1,250 squares. So let's find out what one car is worth by dividing by 250 both sides, which is 5. So 5 squares equals 1 car. Now I had 600 squares here, so all I'm going to do is do 600 squares divided by 5 squares to work out the frequency for this. So 600 divided by 5 is 120. So 120 is the frequency for that one. Next one, was 130 squares. So 130, remember 5 squares is worth 1 car, so I divide that by 5 to get 26. And the last one, there was 520 squares, so I divide that by 5, because again, 5 squares is 1 car, and that gives me 104. And obviously just double check, add those all up. Do they equal 250? Yes, it does. Okay, so by working out what 1 is worth, by using the area, I can then work out the frequency like so. So I'll just put that one in there because that came up two or 3 years ago. I can't remember exactly now. And I did trip a few people up because it was something they haven't seen before. So hopefully now, if worst comes to worst, just work out how many squares you've got, and then you should be able to do a comparison either individually or in total. So hopefully that helps, guys. Thanks for watching.